I'm Niall Crosson. I'm the Group Technical Director with Ecological Building Systems. I've been working with the company for 21 years and I'm also a Passive House consultant as well as a member of the Board of Directors with the Irish Green Building Council. Ecological Building Systems as a company, we not only supply a range of natural fibre insulations, high performance air tightness and wind tightness materials and natural paints, but we also provide full technical support, training and education, and we very much promote the use of bio-based, more natural materials. There are over 300,000 bungalows throughout Ireland. In the UK you have over 7 million traditional buildings, which may not be bungalows, but many of them need to be retrofitted. And rather than demolishing these buildings, retaining them as much as possible means we're retaining the carbon that was emitted during the original build process, and then also employing materials with a lower environmental impact will further help reduce the impact of renovating the building. And there are all those other benefits which will be discussed today in relation to this project.
So my name is Barry McCarron, current chair of the Passive House Association of Ireland, and work for Southwest College as their head of business development. And we've been in this construction space now of high performance construction for about 10 years.
Yeah, and Szypura from Klimahaus, air tightness installer, Passive House Tradesperson, insulation installer, and just through the expertise that we got over the last decades, really, also consultant.
10 years ago, myself and Aisling, whenever we were getting to that age where you'd want to be getting down on one knee, this house actually came up on the market, and it was post Celtic Tiger, and we were able to buy it for less than €100,000. It's a 1970s bungalow, and at the time when we bought it, I thought that it would be a good house to sell on and make a profit on. But the longer we were here, the more we really liked it, and it became apparent more and more that a retrofit was going to be on the cards here of the bungalow. And then with my role and with everything I've learned over the last 10 years in terms of Passive House, there was only one way to go, and that was really to set out to do Passive House Retrofit. Some could have made the argument that, you know, why did you not toss everything and just start with a blank page? But for me, you know, again, with the vantage point I have with the construction industry, I was sort of aware of embodied carbon and everything that entails, and we were very, very keen to keep as much of the structure as possible. Also, technically the house was really only a retrofit and an extension as well, so for that reason also we wanted to retain as much of it, and very proud we did. So more or less what happened in terms of the bungalow structure, we kept the whole of the rear wall, and we kept the two gable ends, and of course all the foundations and floor. We just went down to the subfloor. So the front elevation was really the bit that got demolished. The old arrangement we used to have from the front of the house to the back of the house, the old garage, and that was converted into a kitchen before we bought it. And where I'm sitting now used to be a sitting room, and like every bungalow, bar none in Ireland, we also had another room, a living room on the other side of that fireplace. So the key thing in every design was this fireplace, and of course the chimney stack with that. In terms of the problems with the house, it was the functionality of the house was that you had two rooms with two stoves, and then you had this kitchen. And in terms of temperature, our kitchen, I monitored the house before we left, and the kitchen was on average 17 degrees. The sitting room that we were in, where we had a stove, when it was lit, the temperatures went as high as 33 degrees. But again, the average, you're talking there around 22, 23. So you're sitting in 22, 23, you go out to the kitchen, it's about 17. And then, of course, because of the dysfunctionality of a bungalow, you then have this room that's part of a corridor to the rest of the house. So it just wasn't very functional, and that really spurred on the design element of what we have today in terms of a third of the house being open plan and the double heights for lots of light and everything. To build on what I said about the temperature differential between the kitchen and the sitting room. Also there was a contrast in relative humidity. The kitchen was sitting where it should, you know, around the 60% mark. And then when we went into the sitting room where we had that heat source, the air was a lot drier. And again, you're talking about 20% drop to around 40, which is quite shocking in an internal environment and only 4 or 5 meters apart. With respect to CO2, because the bad performance of the kitchen, the CO2 wasn't really a concern. In the room with the stove, we were above 1,000 CO2 parts per million. But the one that caused me probably the most concern was the master bedroom would regularly get to over 2,000. In some cases, maybe towards 3,000 CO2 parts per million. So the indoor air quality certainly was variable, but above the typical bar of 1,000. Since we moved into the house, we've also been monitoring the house, and we're sitting here right now in CO2 of just around 500 CO2 parts per million, which is excellent, almost the same as outdoor air quality, but we have this nice comfortable environment as well. It's hard maybe to put the full claim down to the house, and we're only in less than a year now, just over 6 months. But it does appear that you know, we're having less symptoms in terms of hay fever and also mild asthma, which 1 or 2 of the kids had. So the mechanical heat recovery unit, what's very, very good about having it in the house is it's now app controlled, and with that you get the indoor air quality data on your app, and then I'm also monitoring the house, so you're able to see, you know, by looking at both and configure it both to see are they both within touching distance of each other, and they are, and they're consistent. And because I'm looking at it probably too much, I now understand exactly what's happening with the house. And in some ways, and this is a bit of a joke, the house is sort of boring because nothing really moves. It's very stable and performing really well. In terms of condensation, we did have quite an issue. Again, like anyone that lives in a bungalow, you're going to see condensation. Very typically, what it would be is you open the curtains in the morning during the heating period, the winter time, and you'd see a bead of condensation along the rubber at the bottom, and that's typically because of the aluminium cassette in the double glazing. And then when we got to the demolition phase, when we were decanting the house, we started pulling out some built-in furniture in the bedrooms. We started taking off skirting boards, we started pulling out the kitchen units, and there was mould. And there was quite a bit of mould in various places. Very often where there was a hole in the wall, where there was significant non-air tightness, as you can imagine, and because it was in behind a unit, you had this lovely breeding ground for mould. So again, mould and condensation were a feature. With respect to Passive House, I was going for Retrofit, and the Retrofit standard for Passive House, or the air tightness standard, is 1 air change per hour. And for our whole house, if you were to take all the surface area of the whole house, this is the equivalent leakage area expressed as a square. But we were fortunate enough with Roman's help to actually achieve full Passive House, which is actually just this square. Now, if I had have went with the current building regulations, this would have been the size of the square in terms of leakage area. If you arrived at somebody's house and you seen a hole in the size of the house that your head would almost go through, well, you wouldn't be too happy. So again, that's a good illustration of air tightness, I think, in terms of our house here.
Barry approached me very early on in the project. It was at demolition stage and foundation stage, and that was the first time when he brought the other tradesperson and himself and myself together on the project, just to look at some sort of an air tightness strategy. And I suppose my input there is what can be done, what has been good in the past from experience, and what kind of a strategy is probably a no-no. And then discuss with Barry and with the builder, like as what they're proposing to do, as what type of build-ups they have and work they have, and then basically find that famous air tightness line in the whole build-up and make sure we put it together with products and details that will come together in the end and make that happen to achieve good air tightness. There's actually some areas in terms of air tightness that people are not so aware of, or that are a little bit neglected when you look at them, and one is the foundation. And we started off here with a strip foundation, and we found that they can be notoriously leaking. I think the worst case I ever had was a strip foundation where we found a leak between the screed and the wall 12 meters inside the house, popping out on the floor. So air can be tricky, and it actually travels in gravel, pebble, stone, and we started with a strip foundation here, and one of the first calls, as far as I remember, was that Barry said, okay, we put the screed across the strips, thereby having a continuous airtight layer to start off from. The nature of a retrofit is that you have an existing build-up and a new build-up. So for the walls, it was fairly straightforward, as in we said, this is going to be the plaster. So the plaster, the inside plaster, is the air tightness line for the walls. And then the tricky bits were finding even the dowel, the holes for the dowels for the skirting board of the old bungalow. Yeah. And identifying and finding all those little areas and punctures, and you kind of always deal with a bit of unexpected as well. Like, you know, you look at the big things, oh, what about the roof? But it's really is those little details that make the difference. I was advising a bit what to look for and what materials to use, because it's also an ongoing process. You can't do air tightness and then air tightness is finished and then you move on. So every time the builder was moving something, adding something, removing something, I was actually really lucky to have Barry on site, who was on site basically every day, as far as I understand. So if something caught his eye, he could just get, for example, a pot of the liquid air tightness paint, the Aerosana from Proclima, and address the issue as they go. So the junction between the floor and the wall was really made with Aerosana Viscon, and it was actually Barry doing most of the work.
Yeah, we applied it just at the subfloor to the existing wall and to where the new wall was. It's quite funny, I actually also had a leaf blower out to get rid of all the dust to prepare the surface. That was an interesting experience. And the other area that we would have applied that same product was also when the walls were chased by the electricians as well. And I found it very, you know, somebody that has soft hands, as we say in Ireland, I found it quite enjoyable, in all honesty.
So in terms of air tightness for the windows, that was straightforward. We used a profile tape, like a window tape from Proclima, to seal it. And the strategy was to have a clean, good line on the face of the window and then return the tape back to the reveal. It's a tape which has a bit of a fleece surface, so it takes plaster really well. And we just make sure we have it right into the reveals, and then later on they were using the plaster and basically covered the tape with plaster. And I'd say that was really straightforward. In terms of thermal continuity, that was a bit of there were some details involved.
There was primarily with the windows, even though we had the opes, the windows were actually hung on the outside of the wall on a bit of structural installation was where they were set, and with that they only had to be in front of the existing ope, and as Roman says, we were able to, you know, use the tapes from Proclima to address both the inside and the external side of that. And then when the external wall insulation was then applied, we were essentially wrapping that frame in the external wall insulation, so it was within the insulation layer, and that detail has worked really, really well. Because the nature of the opes that we talked about in a retrofit situation, some of the windows were made bigger, some of the windows in the existing house were made smaller, and then of course we had some new build, so we had a high degree of variability in the shape and the condition of each of the opes. And then when the windows were installed on the outside, it was very important for me to make sure that we could get a warm layer of insulation to touch the window frame, and cork plaster was a brilliant solution. The thing that I liked about it was that we were able to get into all the various nooks and crannies on the, let's say, the damaged oak, and it was able to get in there with the first layer, then a second layer, then a third layer, and then we had this lovely continuity then touching that frame, as I said. So it was a lovely solution, and one detail we're very proud of on the project.
Obviously, there's always some penetrations to the walls, be it cables or the main cable, be it the heat recovery system, the main ducting. The bigger openings, they were all done with this plasterable tape, this Solido SL from Proclima. That's quite easy to put on, to bring around. Smaller openings like cables or the drill holes from the existing old bungalow, we've done it with a combination of the airtight paint again and Orcon F, the airtight mastic from Proclima. But then I believe you also got a grommet, which has an integrated, basically a fleece. So it's an EPDM grommet that goes around the pipes. But then there is a fleece type tape that can be plastered over again. It's flexible, it's airtight, it can be plastered over, it's not seen, it's 100% reliable, and you install it in what, 30 seconds?
Yeah, that's simple.
The roof was a new roof, so there is very little of the usual retrofit challenges.
Yeah.
On the other hand, it was a truss roof, and with truss roofers, it just means if you have a warm truss roof, you have a lot of studs and braces and timbers kind of going zigzag and crisscross. So all the air tightness at the roof is the Proclima Intello Plus membrane and the Vana tapes for the overlap. So it's the Tescon Vana actually. Then the joint and junction to the wall is the Solido SL from Proclima. And again, it was a mix of new plaster, new block wall, old block wall. So wherever we had doubts about the ground, we used a primer or a primer to just reinforce the ground a bit and make sure there's no dust left and that you get the full adhesion of the tape. The real challenge, or what I will always remember, is that it is an L-shaped roof. So it means at some stage you have even more studs and braces going crisscross. And I was really impressed when Barry could send me a 3D model of the roof, and you could actually look at it in 3D. I can draw the line here now and look exactly as where to place my air tightness and what to do. So it's super important to have a good plan. The roof that we finally got was a little different than on the plans. There was a slightly different detail. The initial plan was to basically just cross all the studs and timbers wherever we find them and seal around them. And that then changed to basically doing a kind of a loop version. So instead of crossing a lot of timbers, we decided to loop around the section. That was particularly tricky.
With respect to the roof build-up, we've quite a unique build-up here. We have a concrete tile, and then we've got Proclima membrane counterbattened, and then we've got a 35mm Gutex multiplex on the roof, and then we have 220 deep cellulose, pump cellulose, and then our Proclima Intello membrane for our tightness, and then we've got Thermofleece sheep's wool insulation in that surface cavity before the plasterboard. So it's quite a unique build-up in comparison to traditional Irish builds, and for our builder it certainly was something that he hadn't come across before. But the feedback was that the Gutex was fabulous to work with. They really enjoyed it. Just really easy to cut, really easy to fit. No real problem there at all.
Barry opted for cellulose insulation here for the roof, which is basically recycled newspaper, treated with a salt to make it fire retardant. And it is then pumped through a special machine, through a hose in the voids. And really the beauty of cellulose is it ticks so many boxes. It might not excel in the one category, but it fills the voids completely tight, not leaving the tiniest gap because it can go around all awkward shapes. It goes in behind and around any cables, pipes, like it's just filling it completely. And the next thing is it's relatively heavy for an insulation material, means it has really good thermal mass and it has very good soundproofing properties. And when you install it at the right density, which is the important part of installing cellulose, is really that to get the density that the manufacturer is asking you for, It's almost like a bit of spring-loaded, and it means even over the lifetime of a building, it will follow the movement. So if the timber shrinks or expands, or if something moves a little bit, the cellulose will always move with it. It has good green credentials too.
It does, yeah.
And as an installer, what I like is it's a fairly quick job. Like we installed the 3 tons of cellulose here to the roof in 2 days, I believe.
Yeah. With respect to ventilation, our system here, our mechanical heat recovery unit that we have, 220 cubes of fresh air from outside come into this house every hour. And at the very same time, 220 cubes is took out every hour. And with that, what you're getting is the outgoing air, the 220 cubes leaving the house, will go through a heat exchanger, and the fresh clean air coming in from outside, which gets filtered, will go through the heat exchanger, and the heat transfer occurs with the 2 airs as they pass each other. The final air tightness result, we had 2 air tightness results during the construction phase, one at the end of course, and one just after we had completed the thermal envelope. So our first result came in at 0.69, and I remember Roman ringing me going, this is actually a really good result because we've achieved Passive House Retrofit, but we're that close to Passive House Classic now. We owe it to ourselves to go on that bit. So with some further attention, we were able to get to 0.53 in the end. There are 300,000 bungalows in Ireland. That's approximately 15% of the housing stock, and they're the worst performing. They're typically a D2, and with the targets that are outlined, we have to at least get to a B2. But a point I always like to make when talking about a matter like this is the building regs and the target of B2 for retrofit, it's only the minimum standard. Why would you go for the minimum? You should go for the best that you can when you do it, and that's why I'd be an advocate of going to the Retrofit standard. I've already articulated today that, you know, over the 28-year mortgage that we've took out, we expect to save around 100,000 versus a cosmetic retrofit. The extra over cost for us to go to the Retrofit standard or the Passive House standard was just 14,000 euros, which was about 5% of the build, and that will pay itself back within about 4 years. So with respect to the contractors and tackling things like Passive House and Retrofit, I think they have a large amount of the skill set. I think it would be very important to have somebody on the project, either in a project manager function or a project supervisor that maybe has the experience in terms of just tweaking some little things. And I think the main challenge will be in the air tightness area. But more importantly, I think it's that the strategy follows the 5 principles of Passive House. You know, your insulation levels, your thermal bridging, because you're adding all of this insulation at the junctions of the floor, walls and roof. Your triple glazed windows, which are now thankfully becoming standard. And then this is the bit that I think is important, the last 2 elements of the Passive House standard. You know, you make the building airtight, and I don't think you apologise for that anymore. You make it as airtight as you can because you're going to mechanically ventilate. If you have that, then you're successful. You're going to have a high performance building. Our builder on the job, Owen Trainer, a local builder here in County Monaghan, he had never been involved in a certified Passive House project before, and I really have to salute him. Airtightness is a team effort, but the thing that I remarked most about the builder was the can-do attitude and the progressive attitude towards, you know, the right outcomes. And on the project, I think that was the secret sauce in many, many ways. Being there for the first airtightness test, and then, you know, seeing what needed to be done, and also the little levels of detail, the minutiae that there is between 0.69 and getting to the result that we did get at 0.53 is certainly something that I think Owen appreciated, and I'm proud to say now he's now a certified Passive House tradesperson, so he's come full circle and he's enjoyed the whole build. So if I had 3 tips for anyone embarking on a project, it would be along the lines of the following. First of all, in terms of planning is the single most important thing. I think the lead-in time to a project shouldn't be rushed. When you're ready to go and you're confident to go, that's when you go. And I think it's no harm in having multiple iterations of plans. You don't have to go with the first plan that you get in terms of an architect, and refine and refine and talk to who you trust in the industry. That would be the first piece of advice. The second piece of advice I would have is to go for the best standard that you can build to. You won't regret that, but you certainly might regret not doing it, and I really feel very strongly about that. And again, the narrative, the consistent narrative always is, you know, build to the building regulations, but I don't think enough people ever say that that's the minimum standard that we should build to. And then the third and final piece of advice is really, when it comes to budget, is to put your money into the things that you're only going to get one chance at. That is the insulation, that is the floor, the walls, the roof, the structure of the building, your windows. Get the one-time hits right, and again, I don't think you'll regret it.
It was very much a team effort in this project. It was very much a whole house approach that was used to make sure that all trades integrated together with regular updates and meetings and processes throughout. So at the end of the day, we can see it's delivered an absolutely exceptional house. I think it's a real template that many others can follow on how to achieve a high-performing, low-energy house with more natural materials without that performance gap that we see so commonly in other projects. The proof is in the pudding from the figures that Barry has, not only from a performance aspect, but also for economics. We can't afford to be spending a lot of money on heating our buildings. It makes more sense to put that money in at the beginning, and then that returns on itself after a short number of years, and then you have the comfort and all the other health and well-being benefits you get from living in an environment like this.